In that same, sorry, in that same study, 30% of coots had movements across the landscape, and a proportion of them came back to their home wetland. Landscape genetic data, landscape genetic studies of gallinals show that they have limited intra-island movements and that drainage ditches and streams could be serving as movement corridors. And through band resites, there have been documented intra-island and inter-island movements of Hawaiian coots. Angelis and Pratt observed coot abundance for a decade, and they predicted that it fluctuated with rainfall due to dispersal to ephemeral wetlands. So I have an example here. This is a Hawaiian coot nicknamed Miss ABC due to her collar letterings. She was banded at Ka'elepulu on the west or the east side of Oahu by Randy Riggs in 2012. So she was resighted at Kealia Pond on Maui in 2023 and traveled a Euclidean distance of 91.45 miles. So from biannual waterbird surveys and other observations, we can see that populations of these Hawaiian waterbirds are fluctuating throughout the year, which could imply that there's movements to other wetlands. But the question is, when are they moving, and are these movements influenced by environmental factors? So learning about coot and gallinal movements can be important for fully understanding their life history and applying that to conservation management. So we wanted to explore that more, and our main question was, are there seasonal movement patterns of Hawaiian coots and gallinals at different scales? So we wanted to tackle that large question and parsed it out into smaller research questions, which were, does rainfall, water availability, and water quality affect short-term population abundance? Is the Kailua wetland complex a closed system for Hawaiian coots? Are there seasonal migration patterns of Hawaiian coots and gallinals? And lastly, are home range sizes influenced by season? So we have a lot to tackle today. So this is just going to be a brief methods of everything we did to answer our main question. I'll kind of go into more specific methods as we tackle each question. But our main study site was Marine Corps Base Hawaii, which is located on the east side of Oahu. We had also two other peripheral wetland sites, Hamakua Marsh Wildlife Sanctuary and Ka'elepulu Pond. So we were conducting weekly waterbird surveys at all three sites and collecting water level measurements at Hamakua and MCBH. Twice a week, we're also collecting water quality at all wetland sites at MCBH. And we were curious about rainfall data. So we downloaded rainfall data from NOAA, a NOAA weather station at Moku'oloi or Coconut Island, which is really close to MCBH. And we also captured, banded, and attached satellite GPS transmitters to a subset of Hawaiian coots and gallinals at Marine Corps Base and at Hamakua. So getting into our first question, we wanted to know if rainfall, water availability, and water quality affect short-term population abundance. So to tackle that question, we used our Hawaiian coot population survey data from Pa'akai, which is at MCBH, and we assessed abundance as a function of environmental variables. We decided to evaluate coot abundance because our gallinal population stayed pretty consistent throughout the study, while the coot populations fluctuated from 7 to 105 individuals all within the same year. And Pa'akai was the ideal site to evaluate that because it housed the largest coot population on base. So coots were counted at Pa'akai twice a week, and we also collected water level and water quality at a stationary gauge. We also looked at the sum rainfall 3 days prior to survey. So in total, with all of those environmental factors, we conducted 54 surveys, and all the data is from the beginning of 2024 to March of 2025. So we assessed this question by fitting a generalized linear model with a Poisson distribution in R. So here are our prediction plots from our linear model, which predicts coot abundance at Pa'akai over different environmental variables. So we used all of our original water sampling variables except for specific conductance because of the high collinearity with salinity. We had to log transform rainfall because of the skewedness. And the stars on each of the graphs are the average for each water quality variable. All of our variables had high significance, but today I'm only going to focus on water level, salinity, and rainfall. So we thought that those variables were the most interesting, and they're pretty accessible for other wetland managers to collect. So first, looking at water level, we see a positive correlation between coot abundance and water level. Pockeye is a relatively shallow coastal wetland, and the higher water levels could be providing optimal foraging depths and healthier water quality for a more productive wetland. Next, looking at salinity, there's also that same positive correlation, which is a little counterintuitive of the positive correlation with water level, as higher salinity is associated with lower water levels. We think it's kind of doing this upward trend because there was a high population influx at the end of 2024 during higher than average salinity levels, which may be influencing the plot a little bit. It is to be noted that coots do feed on algae growing at Pockeye, and some of these algal species do better in more saline environments. Lastly, just looking at rainfall, we see a negative correlation between coot abundance and some rainfall. Although we could be undercounting in extreme rain conditions, our results reflect the similar predictions from Angilis and Pratt in 1993, which forecasted that coots were dispersing to ephemeral wetlands during heavy rains. So just to kind of wrap everything up, there's some trends in the model that may have been influenced by this large population influx at the end of 2024. And the collective movement of coots could be due to the conditions at the departing wetland versus the conditions at Pockeye. Or there may be some other factors that we aren't kind of looking into, like carrying capacity, that could be affecting the population abundance at Pockeye. Okay. Next, moving into the second objective, we wanted to know if the previous rapid changes in Hawaiian coot population at MCBH were a result movements between sites, or if they're coming from other wetlands on the island, or maybe even from other islands. So the outcome of our R-squared model would tell us how correlated 3 coot populations in Kailua are, giving us insight on coot movement networks. So a positive R-squared would mean that it's an open system and populations are changing simultaneously and coots are immigrating from other wetland population sources. A negative R-squared would kind of indicate a closed system where abundance has an inverse relationship between wetlands and Kailua, and birds are moving from wetland to wetland nearby. So we used our coot population data from weekly waterbird surveys at Pockeye and Kaluapuhi, Hamakua, and Ka'elepulu from the beginning of 2023 to about March of 2025. So here's just kind of the R-squared between all 3 sites. We have Pockeye, Ka'elepulu, and Hamakua, and there's a positive R-squared between all of them, meaning that the populations are correlated and moving synchronously, which implies that other coots are entering the population and dispersing amongst Kailua wetlands. So at the end of 2024, like I said before, there was a spike in population at all 3 sites, especially Po'akai and Ka'elepulu. We're not really sure where they're coming from, but in my next section, we're going to maybe cover where they're going. We kind of grouped Po'akai and Ka'elepulu together in site and coot behavior similarity. So both of these sites house coots that flock together and they don't seem as territorial versus Hamakua, which had stable populations throughout the study and observations of high territoriality. And we think that this is maybe because of the higher quality of habitat from DOFA's rigorous habitat management. And that could be maybe explaining the lower R-squared between sites connected to Hamakua. It'd be good to know why there are so many irregularities in timing of population changes. And based off of personal communication, it seems like there's rapid population changes of coots at wetlands around Oahu. And it'd be good to piece together that kind of movement to see some intra-island wetland connection. Here's just a graph of the population counts over time. So this graph starts around February of 2023 and it goes through March of 2025. So Hamakua is in blue, Ka'elepulu is in red, and Po'akai is in yellow. So if you just look at Hamakua, you can see over time that it's pretty constant and flat and the population doesn't change that much. But in the end of 2024 and into early 2025, there's kind of that jump in population, especially at Pakai and Ka'elepulu. And like I was saying before, we kind of predicted that the the population didn't change too much at Hamakua because of territoriality, and there might be maybe immigrants being excluded or not much emigration either from Hamakua, but more birds coming into Pa'akai and Ka'elepulu. And the population did seem to change a lot over time. We checked back in July this year, or I checked back in, and the population was back down to an average of 25 at Pa'akai. So in January is around 100, and now it's dropped back down to 25, which is kind of interesting. Okay, moving on. My third objective, we wanted to know if there are seasonal migration patterns of Hawaiian coots and gallinals. So we assessed that by capturing and banding 49 gallinals and 19 coots, of which a subset of 15 gallinals and 17 coots received satellite GPS transmitters. We monitored them for the entirety of the tag life. The average time monitored was 156 days for Hawaiian coots and 267 days for Hawaiian gallinals. It's to be noted that I calculated that in April 20th of 2025. So those numbers could be changing. We currently have 4 gallinals and 6 coots still actively transmitting data. So we just monitored these birds for its tag life just to see where they went and if they were moving off their home wetland. So we had 4 coots that had movements off their home wetland, and all of them were pretty significant distances. But today we're just going to focus on one bird. This is ZAGY. She was transmitted at Pa'akai, and she departed to Ni'ihau in May of 2024. She traveled a Euclidean distance of 157 miles, and the movement was flown between fixes within an 8-hour interval. And also, this is the first record of a Ni'ihau coot dispersal, which was pretty neat. She attempted to return back to Oahu in September of that same year. She had stopovers in Kauai, but ended up settling down at a Turtle Bay golf course on the north shore of Oahu. She was hanging out there for 8 days before the end of her transmissions, and we weren't really sure why there was an end of transmissions, but she did fly pretty far, and the picture on the left is a picture taken by someone renting a Sunset Beach beach cottage, and she stopped on their porch, I think, right before heading over to this Turtle Bay golf course pond. So it's interesting to see my birds in situ, observed by a tourist. Anyway, so we had some other coots that traveled. They went to the north shore of Oahu. James Campbell seemed to be a popular stopover site, and also to the west side of Kauai. Okay, so moving on to gallinals, we didn't see too many movements from Hawaiian gallinals, but the ones that we did see were pretty interesting. We had one gallinal that had an exploratory foray around Kailua wetlands over a 5-day period, which you could see to the right. She traveled a total Euclidean distance of 13 miles before returning home to her small wetland site, TLF. We knew that she wasn't a part of a breeding pair, and we speculated that she was searching for mates or for maybe some suitable nesting areas. We wouldn't have known about these short exploratory forays with the outer transmitters, providing detailed information we wouldn't just be able to see from band resites. That being said, we did see a couple movements through band resites as well. We had 2 movements from Hawaiian gallinals. We had one juvenile Hawaiian gallinal that was banded at Pa'akai, seen a couple months later hanging out at Clipper Golf Course, which is still remaining as of July of this year. We also saw a Kailua Dofa gallinal that was either banded at Hamakua or Kuainui, hanging out at TLF for a day in January of this year. But again, we only spotted it once, so we assumed that it just moved on somewhere after that. So based off our transmitter data that we see that coots and gallinals do move, but we didn't see any seasonal patterns in their timing of movement. What was kind of interesting was that all the individuals that dispersed were female. Um, we've I've seen or I've read about uh, female dispersals being common within mammals and some species of birds, and male resource defending species tend to have more female dispersers or females that are dispersing further different distances. And this behavior has been seen within the family Rallidae, which coots and gallinals are from, with king rails. So in one study, it seemed like females were being pushed out of suitable habitat during the non-breeding season and were more likely to disperse because of the males kind of being territorial of the good habitat. So maybe our coots are following a similar pattern when it comes to dispersal, and females are being the ones are more willing to disperse rather than males. Okay. Um, I'm just going to move on into our last objective. So we wanted to know if home range sizes were influenced by season. So for that, we used our transmitter data and we fitted bivariate kernel densities in R to evaluate that. So our transmitter data had, or transmitters had 3 fixes a day. We categorized home range by a 95% kernel density estimation, or KDE, and core range was a 50% KDE. We defined the wet season as November 1st through April 30th, and the dry season as May 1st through October 31st. So we predicted that home ranges were going to be smaller in the wet season, while birds may be nesting or defending territories for the breeding season. Okay. First, looking at Hawaiian coots, there was a slight effective season on home ranges, but not with high conviction. So on the right, you could see the monthly home range of a Waipuna coot. It's showing February, which is in blue during the wet season, and May during the dry season, which is in red. And we see that the dry season home range is a little smaller than the wet season home range. We think that the dry season home range could be smaller due to the delay in nesting at MCBH. So of the few coot nests that we did have, we noticed that these birds were nesting later in the season or nesting later in the wet season or earlier in the dry season. Originally, we expected to see smaller home ranges in the wet season, while birds may be defending territories or sitting on nests. But maybe these wet season home ranges were inflated at MCBH in preparation for the early dry season nesting. So, but overall, there was not much change between seasons, and that could be due to the low nesting rates and tagging of younger individuals. If we had tagged more breeders and individuals in general, maybe we could have seen these effects more strongly. Next, looking at Hawaiian gallinals, there were no seasonal effects of home range despite many nesting efforts. So the gallinals at MCBH seem to have distinct territories and occupy much smaller wetland areas compared to coots. Granted, their behavior is pretty different. There could be no effect of season to Hawaiian gallinals because of the spread of nesting concentrations. They were kind of nesting all year round. So maybe territoriality was offset by different individuals at different times of year. This particular bird seemed to have a shift in area along with some other gallinals. They may be seasonally shifting their core ranges depending on food availability or other resources. So in August, during the dry season, which is shown in red, it's kind of inhabiting like a woody wetland kind of area where there's more trees. And versus the wet season, it's in December, it's kind of it's shifting over to the center of the wetland where there's more kind of like sedges and typical emergent wetland habitat, which was kind of interesting to see. So just to wrap up, the key takeaway from this is that these birds are pretty unpredictable in terms of population changes and individual movements. And unfortunately, the scale at which we're studying these birds is just not long enough since there's so much variation in timing and movement destination between individuals. So maybe if we deployed more tags, we could potentially capture these movement trends of these water birds. From this, we could delineate that water-related habitat factors and weather influences on Hawaiian waterbird abundance, and that the Kailua wetland complex goes through unpredictable fluxes in terms of coot abundance. We didn't see any seasonal patterns in timing. Granted that our two focal species are very different in movement behaviors and timings, but it's kind of evident that coots are moving more than gallinals, but interestingly, all movements were between female birds across both species. As a side note, observing these fine scale movements through our satellite GPS transmitters have revealed lots of information. The most common stopover sites included state and federal managed wildlife refuges, agricultural land, and golf courses. So maybe safety at these unmanaged stopover sites may be important for safe passage of these moving water birds. We were unsure if the coot movements were dispersals in search of better habitat or migrations with the intention of returning to a home area. There was large variation in movement, timing, and destination. So again, more individuals transmitted and more time tracking could maybe reveal some unseen patterns. And lastly, we observed that coot home ranges were slightly larger in the wet season, while some gallinals had a seasonal shift in core range. Okay. So from this, we want to know if there are seasonal movement patterns of Hawaiian coots and gallinals at different scales. And the short answer to that is no, although there seems to be some effect of weather on coot abundance. But now we know more about these endangered birds' population, movements, information on wetland connectivity and migration or dispersal behavior, habitat preferences, and home range and space use. And again, the key takeaway from this is that these birds are pretty unpredictable in terms of population changes and also in individual movements. So collaboration on coot population observations between wetland sites and more time tracking birds could really help piece together a movement network and maybe identify some key breeding areas versus loafing and stopover site areas. Water and habitat quality, along with wetland carrying capacity, are all factors of Hawaiian waterbird abundance, and we should keep territory size, seasonal abundance fluctuations, water quality, and extreme weather seasons in mind when planning for Hawaiian waterbird conservation in the future, especially as sea level rise threatens vital waterbird habitats. So these Hawaiian waterbirds are sometimes on the move, but with our collective continued efforts, they could be moving away from the threat of extinction. So I just wanted to say some thank yous before I take any questions, and thanks for sitting through this webinar so far. But yeah, thanks to my funding from DoD, specifically ERDIC and CSU for hosting me for my master's. And thank you for Caitlin Wells for being my professor and guiding me through all this. And so yeah, special thanks to Marine Corps Base for coming up with this project and hosting me as and having that place be the main study site. Also, thank you to DOFA and specifically Aaron Works for allowing me to add Hamakua on as an additional site. My studies could not have been done without my technicians. So thank you, Mercedes, Dale, Calypso, Koa, and Jaime. I really couldn't have done the work without them. So there's a lot of other people that I need to thank for my project, but there's just not enough time. So I do appreciate everyone that's been a part of my project and helped me along the way. Just one more thing, an update for my master's. I am currently working on my second chapter, looking at nesting preferences of Hawaiian gallinals in terms of vegetation and water quality, and I'm set to defend my master's thesis at CSU in October. And I am actively searching for a job. So if anyone like to contact me, my email's in the bottom right corner. And other than that, that's it. Thanks for listening, and I'll be taking any questions.
Thanks so much, Lisa. Much appreciated and well done. I'm just going to throw the floor open. Does anybody have questions? You can put your hand up or just dive in there.